In this next case, I've multiplied problem number 6 by x, and I can factor out that x and have x squared minus 25 equals 0, which again further factors into x plus 5 times x minus 5. Well, this time the x out front is a variable, and this was an x to the third cubic equation, which suggests that we should have 3 solutions. And if we were to write the zero product rule out, the first part we'd have would be x equals 0, or then the x plus 5 equals 0, or x minus 5 equals 0, and that would tell us we have the 3 possible solutions of 0 plus or minus 5. In the case where we have a factor of 2x going into each term, factoring out into x squared minus 25, it will still factor down to 2x times the x plus 5 times x minus 5 equals 0. But when we have the 2x equals 0, we can't ignore that 2 out front the way we did up in problem 7. The 2 will divide off and give you x equals 0 there. So again, we will have 3 solutions of 0 and plus and minus 5. So I wanted in those last 4 problems to kind of show you the different variations that can occur. For this quadratic equation, it's not set equal to 0, so we want to bring the 3 to the left. That gives us 4x squared minus 11x plus 3, because we're adding 3 to each side, equals 0. When it comes to factoring this, we notice that 3 is a prime number, so 3 and 1 will be how this factors, and it turns out that it is going to be x minus 3 times 4x plus 1 equals 0. And I really recommend you check your inner and outer parts of FOIL to verify that minus 12x and plus 1x do make that minus 11x in the middle that we're looking for. Now we should have answers of x equals 3 or negative 1/4. Don't forget, when there's that leading coefficient of 4, it needs to divide off to the denominator. Or better yet, you actually say x minus 3 equals 0 or 4x plus 1 equals 0 and solve each equation separately. This one on the right gives you the negative 1 on the right, and then dividing by 4, you now see your fraction. Since this next problem has an m to the third in it, we would expect to have 3 solutions to this problem. I can factor out an m, leaving me with 2m squared minus 5m minus 12, and that will factor further into m. 2m plus 3 times m minus 4 equals 0. Notice when I check my inner and outer, I have a minus 8 and a plus 3, making that minus 5. And so my 3 solutions will be 0, negative 3 halves, and 4, all of which will check back in the original problem. For number 12, there are only 2 terms here, but I can still factor out a 2y, leaving me with y minus 10 equals 0. And you can see very easily that y will equal 0 or 10. For number 13, it is not written in a form set equal to 0, so I will bring that minus 20y to the right-hand side. I now have 2y cubed plus 14y squared plus 20y is equal to 0. And all 3 terms are even, and all of them contain a y, so 2y will factor out, leaving us with y squared plus 7y plus 10. Now this will factor further into 2y times y plus 5 times y plus 2. And then you can see that our 3 solutions will be 0, negative 5, and negative 2. Number 14 is a quadratic equation because it's got that x squared in it, but it doesn't have this nice, neat set equal to 0 pattern. So we've got to do a little bit of cleanup on this before we start the factoring. We will have 3x squared minus 6x minus another x equals 3x squared plus 4. And then we notice, hey, I've got an x squared, 3x squared on each side, which will subtract out. So this really isn't quadratic at all. Combining on the left, we have minus 7x equals 4, and therefore the only solution will be negative 4/7. So that was kind of a linear equation in disguise for this problem. For this next problem, even though you see it factored on the left, don't say, hey, my answers are 1 and negative 2. That's only if it's set equal to 0. For this problem, we actually have to do all the distribution out on the left and rewrite this as x squared plus 2x minus 2 equals 18, and then combine like terms and subtract that 18 to the left, giving us x squared plus x minus 20 equals 0. Now that it's equal to 0, I can apply the zero product rule, factor it into x plus 5 times x minus 4 is equal to 0, and have my two solutions of negative 5 and positive 4 become evident.